All right, good morning, everyone. So I think I shall start because we have to end early. You have one midterm, some of you have a midterm test at 11 o'clock. All right, so we will try to finish at 10:45. All right, okay, so there are a few announcements that I would like to make. So first of all is your assignment presentation. So next week will be your presentation for your assignment. So we will schedule the presentation during your practical section. So you'll present your solution to your tutor, all right? So your tutor will assess your presentation during the practical section. So make sure all of you, all your team members, attend your practical section, all right? Okay, accordingly. And then for the presentations, all right, so we would like you to actually prepare slides because I believe that it's quite impossible to test the whole setup of your network. It's going to take longer. Okay, so we would like to hear from you about your proposed solution. So you are given 10 minutes, all right, 10 minutes including 4 minutes demo session. Right, so you will need to present your slides within 6 minutes. All right, so you have 6 minutes to present your slide. So within that 6 minutes, so I would like to encourage you to actually prepare only 5 slides. Okay, so you just spend around 1 minute to talk about one slide, all right, or less. So the slide should be arranged as follows. So slide number 1 will be the name of your team members. So introduce your team members and then explain their contributions, okay, to the project. Okay, and then your overall design, okay, the diagram or figure, image of your overall design. So please explain as well. Don't just simply show the design and then that's it. Okay, you need to explain a little bit what are the choices of your topology, why you design as such, and so on. Okay, all right. So that will be around 1 minute of your presentation or explanation on the overall design. Then slide number 3 is a list of requirements that met. Okay, so you identify in the requirement handout, in the assignment handout, what are the requirements and which requirements that you have met. So you can think about ways to present this information, all right? So, and then, are there any requirements that you do not met, okay? Are there any changes to the requirement, okay, for example, from the HTTP to static and whatnot, okay? And then, if there is any additional features that you add on to the requirements, okay? Or you add on outside of the requirements of the assignment. Okay, so you can outline everything here in one slide. So think about the way you want to structure the information here. And number 4, strength of your design. Okay, what is the advantages or strength of your design? And number 5 would be the limitations of the design and the proposed future work. So this should be all outlined in only 5 slides. Okay, because you only have 6 minutes to present. Okay, by 6 minutes I will ask you to stop. Okay, the tutor will ask you to stop and we will straight away go to the demo session. Okay, so the demo session, we will basically ask you to test and verify the connection as per outline in part 3. Okay, part 3 of the assignment. All right, so we will test and we will select a random PC or devices to test the connection. All right. Okay, so basically that will be the arrangement for the presentation. Okay, so for the submission, this Sunday, right? So this Sunday will be your due date for the assignment. So you have to submit your assignment report, okay? And then the CPT file, okay, .pkt file, and then your presentation slides. Okay, so that would be 3 files that you have to submit by this Sunday. Okay, so that one is the assignment. Okay, and then today's session I have scheduled a replacement for tutorial section 1, 9, and 10. Yep. Yes, correct. Okay, so I'll make correction on my times. Okay, so it should be Sunday, 11:59 p.m. Exactly before Monday. Okay, before Monday, Monday 0:00 a.m. Something like that. Okay, so today I'm going to have a replacement section for practical 1, 9, and 10, which basically a consultation hours. Okay, So this is going to be consultation hours between 12 to 3 p.m. So I'm going to open this to everyone. And some of you do have class with Mr. Chew. Okay, so you attend Mr. Chew and you can consult Mr. Chew. Okay, for those who are under Dr. Akibu and my class, or who do not have class within these hours, you are free to come and consult regarding your assignment. Okay, from 12 to 3 p.m. And I will announce the venue in the WhatsApp group. Okay, all right. And then they're going to be online session as well to replace the tutorial for group 1, 9, and 10. All right. Okay, and then in the assignment, you have to state your assignment ID, group assignment ID in the form, Google form. So you can refer to this grouping information, Excel sheet, to identify your group assignment ID. So let's say I click on Dr. Akibu tutorial section, okay, practical section. So your team number here, this is indicative of your group assignment ID. So go to the document, identify which group you are in, and that would be, and look at the team number, so that would be your group assignment ID. Okay? Right, so, and then the next one, okay, the OS Labs marks for practical, for my practical has been released. Dr. Akibu also, I think, has released his mark. So Mr. Chew is on the way. Okay? On the way. All right, so I think basically that's all. So for today's lesson, we will need to cover 2 lectures, lecture 10 and lecture 11. Okay, so let's start with lecture 10 first. Okay, so for lecture 10, we will talk about error detection and correction. Okay, so how are some of the devices or some of the framework detect errors in the packets, and how they can correct the errors. But mainly we are talking about correction detection at the moment. We do not talk about the methods to correct. Okay. Now let's look at the methods. First of all, you need to identify I think I'm going to open from let's see. All right, so first of all, we need to know what are the errors, okay, that exist in the network transmission, okay. So an error occurs, okay, when an error occurs. An error occurs when a bit within the packet is altered, changed, okay, between the transmission and reception. So what the sender sent is different from what the receiver received, okay. So for example here, of course, the sender is sending 101010 packets. So definitely the either binary 1 is changed into 0 bits, or binary 0 is changed into 1 bit. So it's just a switch of bits. Okay. So the errors could be a single bit errors, or it could be burst errors. Okay. So what is the difference here? So single bit errors refers to an isolated error that alters only 1 bit. Okay, 1 bit, but does not affect the nearby bits. Okay. So usually it can occur in the presence of white noise, electronic interference, okay, or magnetic interference. Okay, burst errors. This one is referring to contiguous sequence of number of bits, B bits, okay, in which the first and the last bits, okay, and any number of in between, okay, are received in error. Okay, so there's a number of bits that are in errors, not just one. Okay, so this could be caused by some impulse noise. Okay, so for example, your device is shaking, so it might cause some errors. The cable is shaking, okay, or the cable is being bent, so it might cause error as well. Okay, or fading in the mobile network wireless environment. So, okay, let's see, this is the difference. So here, you can see this is a single bit error, so meaning that the nearby bits are not affected. And here you have a burst error, okay, of length of size 10. Right? So you identify the first bit which is in error, And then you can see after 2 bits, there is also some errors in between. So you can classify this as a burst bit. Okay, all right. So detection, how you can detect. Okay, regardless of what design you use, how best your network design would be, okay, how best the technology you use would be, there will always be some errors, okay, in the transmission. So that either resulting in single bit or in number of bits, okay. So usually frames, okay, frames are referring to the packet that is traveling in the cable or in the wireless at the moment, okay. So these are the frames, sequence of bits that are transferring across the medium, all right. So since the data are being transmitted as one or more contiguous sequence of bits, okay, so the probability that a bit will be received in error, okay, so there's always a probability that some bits will be in error. There will be a probability P1 here that a frame arrive without no bit errors, okay. You might also have a probability that the received frame, okay, using an error detecting algorithms in use, a frame will be arriving at the destination with one or more undetected errors. Okay, there is an error, but you cannot detect where it is. Okay, so that you have also that probability. And probability number 4 here is that when an error detecting algorithms is in use, okay, a frame arrive with one or more detected bit errors, but no undetected bit errors. Okay, meaning that some algorithms are able to detect bit errors, okay, and it will be able to detect bit errors. So meaning that algorithms will inform you that there is no bits you cannot detect with errors. Okay, so these are the 4 probabilities, okay, of the potential errors that the resender may have, okay, at the receiving side. Okay, what are the probabilities that will influence the number of errors in the packets or in the frame? The probability that a frame arrive with no bit errors, okay, there's no error, all correct, decreases, okay, when the probability of a single bit error increases. Okay, when the probability of having a single bit error increases, definitely the receiver will not be able to receive a frame without errors. Okay, so that probability will go down. And then the probability that a frame arrives with no bit error decreases as well with the increasing frame length. The larger the packet, the size of the packet or the size of the frame, the more chances you are in receiving a frame with errors. Okay, because the longer frames, okay, will transmit it across the medium, chances are, because it's long, chances are due to some interference and whatnot, you may have higher probability to get error in the frames. Okay. Okay, so this is how the detection process looks like. Okay, so you have data. Okay, so using the data that available in the packets or in the frame, okay, you will supply the data to some algorithms, error detection or error mechanisms correction. Supply this to some algorithms. It will using that data, it will calculate some value. Okay, and then it will append the value to the data. Okay, so the data together with the error detection coding here will be transmitted to the receiver. Okay, and at the receiver side, okay, what happened here is that the receiver will extract data and also the error coding bits. Okay, and then it will supply the data back into the algorithm, reversing the algorithms to get the actual error checking bits here, and it will compare. If the error checking bits here is similar, okay, to the calculation produced by the same algorithms on the receiver side, okay, it means that this data has no error. Okay, but if the comparison shows a differences between what the receiver received and what the receiver calculates, okay, so it shows that the data contains some errors. Okay, so this is the usual mechanism to ensure that the data transmitted between transmitter and receiver do not have any error. Okay, all right. So now let's look at some mechanism that you can use to calculate or to identify errors in the data packet. So first is the parity check. Okay, so this is the simplest error detecting scheme, okay, which is to append a parity bit to the end of a block of data. Okay, so what it does is that it will calculate the number of ones inside the data. Okay, and then it will determine what will be the parity bit for that data. Okay, so let's say if there's any even numbers of bits are inverted, okay, due to an error, you will be able to detect some undetected errors. There's some error, but not detect where it is. Okay, so it could be even parity, which you will calculate even number of ones, and it could be also odd parity, which will calculate odd number of ones. Okay, you can see here. This is one example. Okay, let's say this is a two-dimensional parity checking. So here, this part is the data, B11, okay, until B1J. So this is one data, okay. And then B21, B2J, this is another data sequence, okay, in the sequence. So you arrange the number in the sequence, okay. And then for each data pattern, you identify the row parity bit. Okay? And then at the same time, you also calculate the column parity bit. Okay? Vertically. Okay, at the end of the day, you're going to have, looking at the row parity bit and the column parity bit here, you will find your main parity bit. Okay, for example, okay, let's say this is even parity. So even parity means it will calculate even number of ones. Okay. So here, let's look at the first row. Okay, let's calculate the row parity bit first. So in the first data, you have how many ones? 3. Okay, so 1, 2, 3. So you have to make sure that the parity bits that you will set will make the number of ones in this row even. Okay, so you will add 1 here. Okay, so your parity bit for the first data will be 1. Okay, now let's look at the second row. Second row, you have also 3 ones, 1, 2, 3. So your parity bit will be set to 1, okay, to make this data even. Number of ones here even. Okay, third row, you have also only 1, 1. Okay, so your parity bit for the third row is set to 1. Okay, and the fourth row, okay, you have 3 number of ones. Again, your parity bit will be set to 1. Okay, now let's look at the column parity. For column parity, you can see the first column, there's no ones. Okay, so the value of your column parity will be set to 0. Okay. The second column, 4 number of ones is already even. Okay, so your parity bit will be set to 1. Okay, and then the second part, third column, you have 2 ones. Okay, so your parity bit also is set to 1. Fourth column, how many bits you have? How many number of ones? 3. Okay, hence your column parity for this will be set to 1. Okay, so similar here for number 5, the fifth column, your parity bit for fifth column will set to 1. So by looking at the row parity column and the column parity row, okay, you look at number of ones here, you can see this one, 1, 2, 3, 4. Okay, this one is 1, 2. So both are even, so therefore this will be set to 0. Okay. Alright, so basically there is no error. Okay, so let's look at the example with errors. So you can see here. So this is one way to detect the use of parity check that you can use to detect a single bit error. Okay, so you can see here. let's say this bit change. Okay, twist change from 1 to 0. You can see when this code word is received by the receiver, it will calculate again number of ones. Okay, let's check. Right? Essentially, this one should be 0. Okay, you can see the number of 1 here should be 0. Right? Because there are even numbers, okay, in the data. But the parity bit here shows 1. So chances are this particular row may already have some error. Okay, so this one is, there's no error, there's no changes. Okay, this one also there's no changes. And then you double check the column errors, column parity as well. Okay, so here is there's no changes. Here, if you can see, the number of ones here is odd. So this one should be 1. Okay, but the code that you receive shows it's 0. Okay, so therefore this column may have some errors as well. Okay, so the rest is there's no changes. So by looking at the row column and by looking at the row and the column that contains the errors, it will intersect at this point. Okay, then you can identify which bit has changed. Okay, so parity check is quite easy to use to identify single bit error. Okay, so in this example, you can see this is an example of undetectable errors. Okay, so using the parity bits, okay, there are possibly a number of columns and a number of rows that contains errors. So it will be quite difficult to tell which bits are actually in errors. So it cannot be detected. Okay, it can detect there is errors, but it cannot detect which bits are actually potentially be in errors. Okay, so these are some example. So actually I have prepared, if we have, I think we do have some times. I have prepared one extra exercise here. Okay, I would like you to go to my times. Okay, in the forum. Okay, I have prepared extra exercises tutorial 10. Okay, perhaps we do this quickly. Okay, so let's say here we have one question, okay, on single parity, right? So identify parity bit in the following data. Okay, assuming the system is using even parity. So let's say here you have A, okay, 110, 1010. So what you have to do is to type back the numbers 110, 1010. So what should be the parity bits? You will add a parity bit at the end of the data. So what will be the parity bits? This is the data. Okay, this is the data. Let me highlight this. Okay, and you will add one parity bit at the back. So what should be the parity bit if the system is using even parity? 0. Because number of ones are already even. Okay, you will add 0 here. So this is your parity bit. Okay, let me highlight the value. Right? Okay, anyway. It doesn't change the color. Alright, so anyway. Let's look at B. Okay, so you will append the parity bit at the end of the data. Okay, so now let's look at B here, 0, 1, 0, 1, 1, 1, 0. Okay, 0, 1, 0, 1, 1, 1, 0. So what will be the parity bit for this one as well? 0 as well, because number of ones is already even. Okay, so you will append 0 here. Alright, so I think the way we want to present this probably, okay, so this is data and this is parity bit. Okay, so you will append the parity bit to the data. Alright, so now, so let's apply some two-dimensional parity. Okay, assuming even parity. So 110, 1110. Okay, so let's say here you have this number. Okay. And then okay, all right. So let's look at the parity bits for this one. Okay, so please fill up. All right. Okay. Okay, it's good. What about the column? Column parity? So this one is correct. You can see from at the row level, okay, the number of ones are already, this one is odd, so parity bit will set to 1. This one is already even. This one is already is odd. Okay, so let's look at the column. So what should be the column? Okay, first column should be 1. Okay, and then this one also 1. The third column also 1. The fourth column, okay, 1. The fifth column, 0. Okay, sixth column, 1. Seventh column would be 1. Alright, so this would be the column parity. Okay, just double check. Okay, so now looking at the parity bits, what should be? Okay, 0. Okay, so row parity is already even and column parity is already 1. Okay, so now let's look at the third question. So this following block is received by a system using 2-dimensional parity. Is there any error in the block? Okay, so now this is the sender parts. Okay, when the sender is sending, so what the sender is sending basically? Sender will send this. Okay, let me exemplify what it will send. So 110, 11101. Okay, 11000. Okay. Alright, so it will send the data together with the parity bit appended to it. And it will also send this column parity. Okay, so this is what we call code word, parity code word. Okay, so it will send actually 4 patterns. So 1, 1, 1, 1, 0, 1, 1, 0. So now instead of sending only 3 data, so it will also sending 3 data with 1 code word. Okay, so if you look at this question here, you have 4 patterns. Okay. So the first 3 would be the data and the last would be the code word. Okay. And now you want to identify if there is any errors in the data. So what you can do is that you can arrange this. 1. Okay. So this one would be the parity bit. Sorry. Okay. Right. Okay. And the fourth one would be the code word. Okay. Okay. Sorry. 1, 0, 0. So I missed one more one. Alright. So this would be the code word. Alright, so is there any error? Okay, so let's look at the row. You check row, okay, row by row. So this one already even, number of ones is already 4, but this one should be 0. Okay, this one should be 0. So there should be an error here. Okay, so this column, this row may have some errors. Okay, now this one, 1, 2, 3, 4, this one is correct. So this one, 1, 2, 3. So this one should be 1. Okay, so there might be an error as well in that row. Okay, now let's look at the column one. Okay, the column, this one is correct. The first row, the first column. Second column, 1, 1, 0, correct. Third column, this one should be 1. Okay, so I just highlight here because I cannot do that. In the third column, there might be an error. Fourth column as well. Okay, fourth column, you can see 0, 0, 0, 1. Supposedly it should be 0, 0, 0, 0. Okay, so fourth column may be an error as well. Okay, and then the fifth column, okay, it's fine. Sixth column is also fine. 6, 7 as well is fine. Okay, so chances are there might be some errors in the first and third row and in the third and fourth column. All right. Okay. Okay. So this is how you can identify if there is any error in the received packet. Okay. So basically that one is parity check. All right. So let's move on to the slides again. Okay. And another one that I would like you to know is the internet checksum. Okay. So this is another way for you to identify errors, okay, to make sure that the packet arrive has no error. So this is the common or popular technique used in many protocols, including IP, TCP, and also UDP. You can check the header information. You will find there is a field called checksum. Okay. So how do you calculate checksum? Okay, so basically you will need to do one's complement addition. Do you remember how to do this? One's complement addition, you have already learned this in computer organization and architecture. Okay, so you have to recall the methods. Okay, but anyway, let's look at one example here. Okay, so this example is already converted the binary into hexa. So basically it is adding the hexadecimal. So you can see first you have to do the summation. Okay, so let's say these are the two data that the computer wants to transmit. Okay, on the sender side, you take the number, okay, and then you add the numbers. Okay, and if you have 3, in this case, it wants to send 3 data. So first data is 0001. Okay, add with the second data 4203, so it will get 4204. Okay, and then these results will be added to the third data, okay, F4, F5. You will get this number. So every time you have a carry, okay, you also need to add the result with the carry. Okay, so you add the result with the carry, you get E6FA. Okay, and then if you do have another data, you keep on adding, okay, until you finish, complete adding all of those data. Okay. And then once you get the final result, you need to do one's complement. You invert the value. Okay, so you have learned this actually in CAO. So once the result is received at the receiver side, what happens is that the receiver will repeat the same thing, adding the numbers again. Okay, and then it will add the results here. You can see it's the same. Okay, it will add the result with the checksum that it received. So once it checked at these two, all the bits should be set to 1. If all the bits are set to 1, it means that there is no error in the data. But if all of the bits are not 1, or at least 1 bit is not 1, so meaning that there is an error in the received data. Okay, so this is one's complement. So I have prepared again one sample of exercise here. Unfortunately, we do not have enough time to do this exercise. You can do this at home, and then you can verify the answers with me, okay, in the WhatsApp group if you want. Okay, you can please try this. All right, so another few sample, okay, is a CRC. This is another technique, all right, which it use some modulo approach to detect an errors, okay. Modulo 2 arithmetic, polynomials, digital logic, and so on. Okay, and then we need to be very fast. Okay, and then there's another one which is forward error correction. okay, which is used to correct of detected errors. Okay, usually requires data block to be retransmitted. Usually, when there is an error detected in the packets, the receiver will send a signal to the sender. Sender, can you please retransmit the data that contains errors? Okay, so this is forward error correction. Right. Okay, so I think I will end here for the lecture number 10. Right. Okay, and any questions so far? Okay, the most important bits from this is to know the type of errors, the parity checksum mechanism, parity and also internet checksum. So these are the three main topics, okay, for this lecture. And the last one that I would like to highlight here before I end is lecture 11. Okay, if you go to my times, okay, you can look at lecture 11 down here. Okay, I have changed lecture 11. Previously, it was a slide. Okay, and I feel that it may be difficult or challenging to some of you to understand the concept because you have to refer to the textbook as well. Okay, sorry, this is tutorial. So I have modified, I have changed the lecture 11 so that it becomes a notes instead of slides. So I used some materials from the Indian College. Okay. So these are the introduction of wireless LAN. Okay. And for this wireless LAN, it introduces you to what is wireless LAN, the advantage and disadvantages of wireless LAN, the technology that you will use, the radio signals, okay, that you use to transmit the data. Okay, so this is wireless LAN technologies. So you have to understand how infrared works, okay, how UHF works, okay. And then you can see here, okay, so these are UHF, okay, and then you can see this is also another important topics, IEEE 802.11, okay. So please go through these parts, okay. So this is the infrastructure base. You have done this for your assignment, some of you. Some of you use access point. So this is what we refer to as infrastructure-based wireless network. Come again? You can include this as your reference. No. Okay. So you have field wireless LAN here and you have access point. Okay. And definitely you need some infrastructure devices to connect to this. And you also have an ad hoc wireless LAN. Okay, an ad hoc wireless LAN meaning that it has separate wireless LAN. So most of you are actually using, I think all of you are using infrastructure-based, okay, wireless LAN. No one is creating the, I think some may be having this model, okay, ad hoc, all right? But majority, I believe, are using infrastructure-based. Okay, so you can read through this, identify the difference, okay, between the infrastructure-based and also ad hoc wireless LAN. All right, okay. So in the some of you are using SSID as well, okay, to separate, for example, the guest network and the employee network. So that one also is actually infrastructure-based. Okay, so you can read through this part. Okay, so remember in your assignment, you have to include some citations, some references. Okay, there is a mark for separate references and citations. So you can refer if you want to discuss about your wireless design, wireless structure. You can also refer to this note. You can cite this note. Okay, whether you are using infrastructure-based or you are using wireless-based. Infrastructure-based here means you can see here you have three kind of station. Okay, you got station A here, and you have BSS. This is basic service set within this environment for this access point. So usually using this infrastructure, the STA1 here, that machine, can actually connect or communicate with STA2 and STA3 in another station, in another base. Okay, but for ad hoc, these are two separate service. Okay, so STA1 here cannot actually communicate with STA5 or 4 here. Okay, so this is ad hoc. Right? So you might use either one of these. And another part that is very important for this lecture is this one, this architecture. Okay, so you need to know the layers. Okay, and the most important part is this one. Okay, the protocol architecture and bridging. Alright? Okay, and also the detailed management and architecture of IEEE 802.11. So please give a look and put your concentration on the first 10 slides. Okay, 10 pages of these lecture notes. Okay? Alright. So any question? Okay, so I'm going very fast for these two. And I know your mind also not here because you're thinking about another exam. Okay. So I will stop here. Let's take attendance for the class before we end. Okay, your final exam will cover from lecture 5 onwards. Lecture 5 until lecture 12. Okay? Alright. And then I already highlighted some tips just now. So if you take note, then you should know which part are quite important. And then I will share a study guide, okay, in my times for your preparation for your final exam. Okay, so you can refer to the study guide to prepare for your final exam. Okay, so if there's no more questions, I suppose, so I will end the session here. For those who want to consult me regarding the assignment, I will be available from 12 to 3 p.m. today. I will let you know the venue. Okay, thank you.